if you need to solve a radical equation algebraically, the first thing you need to do is isolate the radical. In this case, the radical is actually already isolated, right? So I can skip that first step and square both sides. Why am I squaring both sides of the equation?
To get rid of the square root.
To get rid of that square root sign. So I'll square this and square this. This, what does that x minus 2 squared become?
X squared minus 4x minus 4. Plus 4.
X squared minus 4x plus 4. Because x minus 2 squared means multiply x minus 2 by x minus 2, and you need to use the distributive property. That's what you end up with. On the other side, the square root of x plus 10 squared
X plus 10?
is just x plus 10. That was our goal, get rid of that square root sign.
Oh,
Would it be 2x?
So we're going to solve that equation that we're left with. What kind of equation is this now? Quadratic. So to solve a quadratic, you have to get everything on one side and just leave 0 on the other. So I'll subtract x from both sides. And I'll subtract 10 from both sides. Excuse me. And I end up here with x squared minus 5x minus 6 equals 0. And then factoring is probably going to be your method of choice for solving a quadratic, but we could use the quadratic formula is another algebraic way to do it. But if we go to factor this is going to be x minus 6 and x plus 1. And so what that means is that x equals 6 and x equals negative 1. The last step here in solving algebraically is to check for extraneous roots. Extraneous roots are solutions that are they're solutions to the modified equation. So in this case, they're solutions to this. Can't see that arrow, but they're not solutions to the original. So we do that just by filling it into the original equation and checking. So I would go 6 minus 2 equals root 6 plus 10 to check the first one. So that's 4 equals root 16. 4 equals 4. So that one works, right? That's checking the 6. And then the negative 1 I'm going to do. Negative 1 minus 2 equals root negative 1 plus 10. And I get negative 3 equals root 9. So I get negative 3 equals 3. And is that true? No, that means that that's an extraneous root. It is a solution to x squared minus 5x minus 6 equals 0. So it's not that a mistake was made. It's just it's not a solution to the original. So that's what you would do to solve algebraically. If you're going to solve by graphing, there's kind of two options of how you would want to do that. So we'll look at both of them. The first one is take that original equation, put everything on one side of the equal sign, and then graph the related function. So we take that x minus 2 equals root x plus 10 and subtract x and add 2. So we get 0 equals root x plus 10 plus 2 minus x is the way that I wrote it up here. But it's just moving that stuff to the other side. Or you could move the root to the left side. It doesn't matter. You replace that 0 with a y and then find the zeros of the function. That's one way to solve graphically. Put everything on one side of the equation, replace the 0 with a y, and then find the zeros or the x-intercepts. So that's here 6 and 0, which means that x equals 6. If you're going to solve graphically, you do need to make sure that you zoom out enough to make sure that you actually only have that one solution. The other option is the one that River told us actually, which is just graph each side of the equation and find where they intersect. So we're not looking for x-intercepts here, we're looking for the intersection point. And so to do that on your calculator, you're going to go y equals x minus 2, y equals root x plus 10, second trace, intersect. And that'll give you the point where they intersect. And it's the x value that you're looking for, so the answer is still x equals 6. You can ignore the 4. The y value doesn't matter. There are no y values actually in the equation that you're solving. We're just putting them there to help us solve. So it's the x value that you want.